Go ahead, try this question, beta. This is IIT Jan 2025 question, huh? 2 marks. Give it a try. Okay. You're tossing a fair coin repeatedly until a head appears. So, first thing can be the head appears on the first toss. उसका probability है half. आपने toss किया, head आ गया, done. Or, let me write first in English. Head appears, done. Or, you get a tail first time and second time you get a head. Or, you get tail, and then you get head. Or, you get tail, and then head and so on. This is what can happen. So if I try solving this, you get a head. Probability of head is half. Or पहले tail and फिर head. दोनों का probability half होता है. Or half, half, half. Or half, 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 or and so on. We know or means it should be replaced with plus sign. तो माने बेटा ये हो गया half plus half to the power 2 plus half to the power 3 plus half to the power 4 and so on. It is an infinite GP. Sum of infinite GP is A upon 1 minus R. First term is half. 1 minus common ratio is half. Right? So, what answer are you guys getting? And why? Okay. Can someone unmute and tell me, did I say I want the first head? The expected number of tosses required for head to appear. Not, I didn't say that I want the first head to come. Why are we using geometric? Why geometric? I didn't say we want the first head. We said expected number of tosses for head to appear, not the first head. Why then we use geometric? Anyone? Can anyone answer that? Why would we use geometric? Okay. What are we doing here? Why is this incorrect? If I want to go through this approach, what am I missing out? Come on. Identify what mistake I would have done here. What's the issue here? It's right. We are waiting for head to come after all failed attempts. I say I get head on the first attempt. Then there is nothing failed. The question just says expected number of tosses required for head to appear. And let's say the head came on the first attempt. There was no failure. Then what? I want you to think, I want you to analyze. I mean, if I apply this approach, what do you think? What's the mistake here? Why can't I apply this approach? Why am I getting different answer from what all of you are getting? Anyone? You can unmute and tell me. I want to understand how much statistics we have understood till now. All of you are correct. Answer is 2. But why not this approach? Yes. Good. No. Because we are fine. I have just found out probability till now, not expectation. To find expectation, if you remember, the formula of expected value of x is summation xpx, right? It's summation xpx. It is not summation px. This is just adding probabilities. This is not doing the formula of summation xpx. For summation xpx, I will go ahead and I will have to multiply each of this probability with the value of x. So I would have said that, let x be success, taking value this, failure taking value this. If I would have done that, then it would have given me expectation, right? So actually, the formula of expectation in this case would be summation. Let's say x takes the value k. Probability is 1 by 2 to the power k. This will be from 1 to infinity. That will be expected. All of you are right. You can use geometric. There is no problem there. Because ultimately, we are looking for success. So you can use geometric distribution, even though the word first is missing. It is identification of geometric distribution. वो use कर सकते हो. But थोड़ा और brain open up करना है कि why. So the biggest hint was that I'm getting 1 here. That is the sum of probability. So if someone would have told you, find the probability of getting whatever, expected word would have been replaced. Expected number of tosses would have been replaced by probability required for head to finally appear. That would have been this. Ki head comes or tail and then head comes, or tail and then head comes, or tail and then head comes. This is just probability. And expectation is not probability. Expectation is submission xpx, right? Or of course, all of you have identified it correctly. Since it is geometric, you can simply write 1 by p and get the answer as true. No problem, right? Okay. Take the next question. So here for all of you, I'll just mark the answer also. So it is 1 by p. 1 by p is half. So it will be 2. Okay. So next question, this is for 1 mark. And it says that there are 2 cards. Right? Find the probability. Give me a minute. Where did I leave the question? Two card drawn from pack of 52 cards. Probability of getting heart and diamond. 1 mark. Yes. You do it through any approach. I mean, you could have followed this approach. So it would have given you 1 into 1 by 2 plus 2 into 1 by 2 square plus 3 into 1 by 2 cube. You solve this, you'll get answer as 2. Or you simply use geometric and get the answer as 2. The expected value in geometric distribution is 1 by p. That would have given you the answer. Both are correct. 2 cards are drawn from a pack of 52 cards. Find probability of getting heart and diamond. It says round off to 2 decimal places. Given decimals, round off to 2 decimal places. I'll give you a hint. It says heart and diamond. Word and is used, not or. I think few of you are solving using or and. And there are 13 heart, 13 diamonds. And the word and is used. Now try. I don't know why last time IIT exam was so easy. Does not mean every year it will be easy, huh? You've done this in class multiple times. All of you are getting wrong answer. Yes, one of you have got the correct one. 2. No. 3. So out of 13 cards, you need 1. You need heart and diamond. Out of 13, you need 1. And ultimately, out of 52, you need 2. Right? So 13C1 is just 13. 13C1 is just 13. 52C2 is 52 factorial by 2 factorial, 50 factorial, which is 52 into 51 by 2. So 51 and 26. Solve. And get the answer. What are we getting now? Simple division, just do it and tell me what answer you're getting. 13 divided by 102. Good. 0.12. No, you don't think it like without replacement. You just think you need one heart and one diamond together. It's like from a deck of 52 cards, you're picking up two cards. One has to be heart and one has to be diamond. That's it. There is no need to think that it's happening sequentially. It just says probability of getting heart and diamond, which means you're picking up cards. One has to be heart, one has to be diamond. Can we use independent events formula? You can, yes, but I mean, aren't we already assuming here that heart and diamond are picked up independently? What else would you like to do here? In what sense would you say that to be independent? Because ultimately I'm drawing two cards. So the denominator has to reflect the presence of two cards, right? So if you do probability of A into probability of B, so if you notice, you guys just notice, huh? If I just notice here, this is 13 by, I mean, for many of you who find this way confusing, 13C1 into 13C1 by 52C2, if you just open this up, the numerator is 13, and the denominator, if I don't break this, is 52 into 51, and this 2 goes up in the numerator. So for you who said, Tina, so you said without replacement, you can understand it through that also. So if you notice, this is my first card, 13 by 52. And this is my probability of second card, 13 by 51. So my denominator has fallen by 1 in case you want to understand it in that sense. And I'm multiplying with 2 because I can go ahead and get heart first and diamond later, or I can get diamond first and heart later. So because there are two cases, I get a 2 here, right? So if you want to do it in this method, that first out of 52 cards, there were 13 diamond. I picked up 13 by 52. I was left up with 51 cards. There were 13 hearts. So probability is 13 by 51. You can do that. But I think this would be an easier way to solve. Now, to answer your question of independence, they would not really be independent in that sense because the second card drawn it is affected by what the first card was, isn't it? So if my first card was heart, I want the second to be diamond, and if it was diamond, I want the second to be heart. So there is some independence in that sense, some dependence in that sense, right? So I hope I have answered both of you now. You can use this if you want to understand through that one less card, and you cannot use the independence completely. But still, for me, this is the easiest concept. This is the easiest way. 13 में से एक चाहिए, 13 में से एक चाहिए. There is a and, so you multiply, and total 52 में से दो चाहिए. Okay, fine. So we'll end this here today. Next class, as I said, bring your normal distribution tables. We'll begin with normal distribution and then hypothesis testing. And hypothesis testing is the last thing we usually do in statistics. And we'll also keep one small test like we had today. Okay, thank you.